archive. What's going on, folks? Can you hear my voice? Can you see my face? And I hope the archive is working. I think it's working. I think it is. I think that this button right here means that it's recording. It's either that means it's not recording, and it means it's broken. Stop recording, pause recording. Yes, I think we're good. Because it's saying stop recording, so that means it is recording, so hopefully that works. Anyway, let's play some games here. Let's do this. Because I think this will be a fun times right here. You guys ever play Angry Birds? Oh my goodness. Angry Birds. By the way, I'm getting over a cold, or at least it's either I'm getting over a cold or I'm coming down with a cold. My daughter might have the same cold that I have, so I probably gave it to her. But I've got a real, my voice is all messed up. So I'm going to talk like Batman for today. Today I've got the Batman voice. I'm Batman. Anyway, Angry Birds is loading up. If you guys ever played it, because I think it's interesting. Now, I've been teaching you guys about Tracker. And I haven't been teaching you Tracker just for any other thing. What we've been doing is we've been doing trackers so that we can track motion, right? And when we've been tracking motion, what we're discovering is that the shapes that we see are quite familiar to us, right? And the first thing I have you guys tracking is a very simple thing, which is just a straight line, right? And we're good with that. We know how to track a straight line. And we even know the math of a straight line. It's pretty straightforward, right? It's y equals mx plus b, and all of that kind of stuff. I apologize, by the way, if my video is glitchy. It seems glitchy to me. Is it right if I just turn it off? You don't need to see my face. It's kind of today I have an ugly face today. And you missed me dancing anyway, because I'm rocking out to the, there we go. Yeah, Angry Birds. Alright. I'm going to skip this thing right here. So what I'm going to do is I'm going to zoom out, and then I'm going to fire this bird like this. There we go. Come on, do it. Oh, I missed it. I did it too far. Oh, I suck. Okay, alright, I'll tell you what. Let's kill that thing. There we go. I'm going to fire a can of sardines. Right there. Yeah, buddy. Just kill the whole thing. Anyway, I'll be honest with you, I wasn't playing Angry Birds so I can actually hit the thing. What I wanted to do was I wanted to track the thing. By the way, my computer is just glitching out really slow. I know. What did we do today? Oh, well, we watched Mr. Daldy play Angry Birds. Well, anyway, here's what I did. I'm going to do a new tab. Hopefully this thing doesn't crash on me because I have all of these things. And we'll open... Oh, wait. Where's my Angry Birds one? Oh, no. Alright. I'll tell you what. I'll just retrack it. I'll retrack it on video downloads. Best class ever. I know. I'm just that good. Alright, let's see. Date modified. Let's do date modified. And where's the Angry Birds one that I had? No, it wasn't on video downloads. It was just on straight up downloads. 1 second. I'm looking for it. Hold on. There we go. Downloads. Where's my downloads folder? Do you guys know? Is it in boot camp? Oh, sad. Alright, let's see. No, not video downloads.
System of Angry Birds.
Yeah, I see that, but I don't think I called it Angry Birds. It's not in desktop. Let's see if I can find a downloads folder. Let's open in Finder. Okay, let's see. There we go. There we go. All right. Here's the downloads folder. Let's do the date modified. Angry Birds. There we go. No, that's not it.
That was yesterday.
Yeah, I want something from yesterday because I worked on it yesterday. Huh. Alright. Well, anyway, I tracked it. And I can't track it now because... Oh, I got an idea. Snag it. Snag it will do it. There. Let's pull this video in. You guys are like, what is he doing? Alright, well, give me a second. Hold on. There we go. Here's my Angry Birds shot. And the first one I actually did win it, but then I don't want to... What I want to do is I want to track this thing. So hopefully my computer is fast enough and it will do it. But I don't think it is because look at how many windows I have open. And the thing's going to be all upset at me for tracking all of these things. Oh, I have such a good class today and my computer is just freezing out. Alright. I'll tell you what, I won't be able to track it. I'm sorry, you guys. But I want to show you guys something. Okay, did it... I guess it closed the Angry Birds one. Well, there goes the Angry Birds. So check this out. I don't have enough memory, that's why. Alright, check this out. What's going on? No, this isn't your assignment this week. I just want to show you guys something. I want to show you guys something that I think is really cool. Alright? What I'm doing here is I'm tracking these motions right here. And it actually looks really cool. I'm going to start off with this one right here. Actually, you know what? I'm going to start off with this one right here. I'm going to start off with this shot right here. And what I did was, you guys ever seen a video like this? Why don't we take a minute and then just watch the video? I think I have it inside of this one. No, it's called Shot and Drop. MIT Shot and Drop. Or Shoot and Drop or something like that. Maybe it's Shoot. S-H-O-O-T. There we go. There we go. Shoot and Drop. Alright. I'm going to go, you know what? If I play it on my computer, it's probably going to be all glitchy, so I'm going to put the link inside of the chat bar. You guys chat yourselves, or watch the video yourselves, okay? Go click on it. And what we're going to do is we're going to watch a video, and I'll tell you what the video is all about while you guys are watching it. You got a guy, and he's going to take a billiard ball. You guys know what a billiard ball, right? It's a pool ball. And he's going to drop one of them. That's going to be on the left side. And then he's going to shoot the other one out. And he's not going to shoot it up. He's not going to shoot it down. All he's going to do is shoot it straight out. Got it? And I have a question for you. Which one do you think will hit the ground first? The one that's shot out or the one that gets dropped? See that? The left side is just getting dropped. Okay? And the one that gets shot out to the right. You guys can see this video. So now he's going to basically put two balls on there and have them done both at the same time. Give me a guess now. Is it going to be the one that gets dropped or one that gets shot? Tell me. What do you think?
Oh, I think the one that dropped.
You guys think which dropped? Boom.
I think it's shot.
Did you see it? Did you see it? It was like on 1 minute and 8 seconds. I'm going to scroll back there. Watch it. Watch it closely. Hey, wait. You know what's crazy? Listen to it. What is it? What is it? When you hear it? When you hear the voice? Or when you hear it? Listen. If it were hit at the same time, it would have one bounce. It would go, you know, boom. If it hits at a different time, it would go clack, clack. Right? So what did it do? What did it do? It went boom. It hit at the same time. Is that not crazy? I only heard one too. You know what I think is really crazy is the Mythbusters did the exact same video. Except they took a bullet and a gun and shot it out. And they dropped a bullet and it hit at the same time. Does that not blow your mind? I know. Isn't that crazy? It's crazy to me. But I mean, if you think about it like this. What is causing that thing to be pulled down? What's causing things to fall?
Oh, gravity.
Gravity. There we go. It starts with a G. It's called gravity. Are we cool? Right. Good. How is gravity acting?
Motion.
Gravity is acting in which direction? Down. I love that answer. It's down. Right? It does it pull it up? Does gravity pull things up?
No.
No, not really. Does gravity pull things forward?
No.
Does it pull things backwards?
No.
So it's acting down, or
Center.
more precisely towards the center of the earth, right? Because down over here is different from down in China. Not really. I mean, there's still, you would still point down, but I mean, you know, it would technically be going. You guys understand what I mean? Like, it acts towards the center of the earth, down, as we like to say. But here's the thing that's really cool is, gravity is pulling the ball on the right. It's pulling it down. Gravity is pulling the ball on the left. It's pulling it down, and it's the same amount of gravity, and they're both acting only in the vertical direction. What's going on in the horizontal direction? Well, let's take a look. I tracked it. I tracked the ball. And let's take a look at it. Look at the X position for mass A. All right, so I tracked it too early, and I have a bunch of tracks when it wasn't moving. All right, so disregard that first part over there. But look at this over here. What kind of line is that? It's a straight line. It's a straight-ish line. Right? It's a little bit slanted. It's not a curve. It's definitely not a curve. But it's a straight-ish line. You guys agree?
Linear.
All right. What about this? Let's look in the Y direction. What kind of line is this? See, so like there's a whole bunch of points over here that you have to disregard. In fact, actually, you know what? Let's analyze this inside of let's analyze this in an Excel spreadsheet. Let's do, okay, there we go. I duplicated it. I'm going to go like this. There we go. And you know what I'm going to do is all of this data up here, I'm going to delete these. All the way up to here. Delete. How do I delete? Let's just go delete. Press the delete button. There we go. In fact, you know what we'll do is we'll just delete all of those rows exactly. Delete rows. There we go. All right, so check this out. Look, here's the graph that we've been making before. Why can't I move that graph? I have no idea. Let me just zoom out a little bit. There we go. Here's the Y position of the ball, and here's the X position of the ball. Notice, the X position is kind of pretty much a straight line. And the Y position is kind of pretty much what? What is this called?
Parabola.
It's called a parabola. Exactly. Is that not cool? Come on, that's got to be a little cool.
That's very cool.
Why is it a parabola? Because that is the shape that things make when you drop them. And what's really crazy is by measuring this parabola, we can actually calculate out what gravity is. Today, what we are going to do is we're going to calculate gravity by looking at a bunch of videos. Tell me that's not cool. Oh, come on. Are you guys excited about that? Like, does that
I
like...
like the fact that we can watch videos.
Okay, we're gonna watch videos. We're going to calculate what gravity is just by looking at these things. So this is what? This is the ball shot. Let's call it the ball shot. Ball shot. And I'm gonna, you know what I'm gonna do is I'm gonna get the X and Y position for the ball dropped. Let's get that one. So this will be, wait, I want my tracker data, and I'm gonna go, give me the data for mass A. I'm gonna take that data, I'm gonna copy and paste him right here. But I'm gonna delete this data over here all the way up to where it says, there we go. All of this one right here. Delete that data. So wait, okay. I don't want to delete all of that data. I want to delete this much data up here. And that all I did was doing is deleting the data that was repeated. All right, cool. I'm gonna delete this column. Okay, so this right here. I'm gonna relabel the columns. Okay, this is the X position for the dropped, right? And this is the Y position for the dropped. And this is the X position for the shot. No. Oops, backwards. This is the X for the shot. This is for the X for the, or the Y for the shot. This is the X for the drop. This is the Y for the drop. By the way, if we look at the X position for the drop ball, is it going to be anything interesting? What do you think? Why no? What is it going to give us?
It's gonna give tiles.
No, it's not really. All right, here's the question again. If we look at this data right here, is it going to give us anything interesting? And my answer is no. And the question is why? Why not? Yes, because it's going to be a near perfect straight line. I mean, if you think about it, like the ball that was dropped straight down, how was it moving in the X direction? It wasn't moving in the X direction. Right? That's kind of like looking at the dune buggy that we had and said, what kind of interesting information are we going to have from the Y direction? Remember that dune buggy that was only going horizontally? Well, it wasn't moving up and down, so we're not going to get any information. It's going to be a straight horizontal line. All right, so is it right if I delete that column? Because that's also, this X drop is not useful information. We cool? So what I want to do is I want to graph all of this. I want to see what graph that makes. And we'll do a chart, scatter plot, click that. There we go. Oh my goodness, look at this. Let me delete this chart.
The Y's and C.
What is going on? Does that not blow your mind? Look at it. Look what's going on. Look at the graph. All right, here, let me make this one smaller so you guys can see it. I'll go to 2 point. Look at the Y position. All right, and you know what? This X shot, we already know that that's going to be a straight line, so I'm going to delete that column. That's not interesting to me. Look at this. This is the Y position as a function of time for the ball that was shot, and it's the Y position for as a function of time for the ball that was dropped. But look at the data. What could you say about that data? And let's disregard this last part over here. Let's disregard all of this information over here. Why do we need to disregard that? This part over here.
So that's when it bounced.
Because that's when it bounced. And we're not really, we don't want to analyze a bounce. We want to analyze when it, just moves like that. But it's the same. Is that not cool? I mean, that is so cool. Are we cool?
Yeah.
All right. Mind-blowing, yet confusing. Yeah, I know, it is very interesting, I think. Alright. Let's do this one. Okay. So I did the shoot and drop. Let's do the let's see. Let's do the projectile motion. Alright, so I tracked this one. And all I did was I took a piece of ping pong ball and I just threw it. Like that. And that's it. And then I tracked it. Click, 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 click. Alright, so I'll show you what it looks like. It'll probably be all glitchy. There we go.
You threw it?
Actually, this wasn't me. I found this video.
Oh. Straight line.
Alright, so when we look in the X direction, what do we see? What kind of graph do we see?
Straight line.
It's a straight line. Why is it a straight line again? Now, alright, here's what X is. X is the horizontal direction. Okay, when we're looking in that direction, it's a straight line. Why is it a straight line?
Because there's a constant rate.
Because gravity is acting in which direction?
Downward.
Gravity is acting in the downward direction, which is in the y direction. So gravity doesn't change the speed of the ball in the x direction. Gravity only changes the speed of the ball in the y direction. I'm kind of breaking this motion into two different directions. I'm breaking it up into the x direction and the y direction. If it's a straight line, that means the motion, the speed is not changing. You can calculate out the slope for this thing, right? And if you calculate out the slope, what will that give you? The slope will give you the speed that that ball is moving in the x direction. Got it? Let's look in the y direction now. So on the bottom I have a function of time. Let's look in the y direction. What do you see? What kind of graph is this now? This is a parabola, and it's because gravity acts in the y direction, and it creates this nice parabola. This curvy looking thing that we've come to try to understand. We cool? Do you see the parabola? Yeah. This is y as a function of time. And so what I did was I grabbed all of this data and I put it over here. So here's the time and the y values. All I did was I took the same exact time and y values here. So you know what? Let's do this. Don't show me the x and don't show me that. There we go. See how these numbers right here correspond to each other? Here's the time, here's the y. They're the same numbers. We cool? All right. Now what I did was what I'm trying to do is I'm guessing what this is. Oh, oops. Okay. All right. So what I'm going to do is I taught you guys a little bit about this equation called vertex form. And this was on Thursday last week. It was a really cool one. Vertex form for a parabola. It looked like this. A times x minus h squared plus k. Do you guys remember that? And what did the k do? What did that number on the outside do?
Oh, I told you.
It would take the parabola, and remember what we were doing last week? Is it pushed the parabola upwards,
Yeah.
right? And then this number inside here makes it go right and left. And it would always do something funky, right? Because if this number inside here were positive, it would actually go to the left, which tripped you out. And then if this number were negative, then we go to the right. That's why there's a negative in there already built in. Do you guys remember what that A does? Remember this number out in front? I'll give you a hint.
I told you the card.
Last week Friday, I had a bag of 6 pounds of gummy bears, and I was stoked because apparently they sell gummy bears at Costco. And yes, exactly. It stretches it. Do you remember what I was talking about with the gummy bears? And I said, all right, here, I'll show you. I've got 15 minutes. Yeah, it was a lot of gummy bears. I'm stoked. I'm probably gonna buy a bag for myself. I had some friends bought it in, but anyway, here, let's try this. Y equals 1 times x minus 0 squared plus 0. All right, so this is a regular parabola. Got it? Now what I'm going to do is I'm going to put a 3 here. And what did that do?
Raise it.
It took my parabola and moved it up 3. Cool? I'm going to put a minus 3.
Forward.
That will take your parabola and move it down 3. I talked to you guys about this before. Plus 0. And if I put a plus 0 there, it won't move it up or down. That's it. All right, and then the number inside the parentheses, what does that do? If I put a plus 3 over here, what will that do?
Move to the right.
It will move it to the right 3. No,
No, left.
it moved it to the left 3 because remember the stuff that when moving it to the right and left is a little backwards. It's a little funky monkey like that. So that's what it does. We cool? And if I put a minus 3 in here, it moves it to the
Right.
right 3. All right. So now what I'm going to do is I'm going to copy and paste this. And I have my 2 parabolas. And let's make one. One's green and one's red. Okay, fine. What if I put the number 2 there? What happens to that parabola?
It goes wider.
It goes, Mark says it goes wider. Does it, anyone else? It moves up. No, it doesn't. It doesn't necessarily move up as in it's being pushed up. But what it does is it kind of. I remember teaching you guys about, or I talked to you guys about this, and for those of you, there we go, Raven's got it. It gets skinny. Well, think about it like this. You ever eat? All right, so maybe I'll show you guys the video on this real quick. Do you guys ever eat gummy bears? I talked about this. I'm going to do this real quick. Have you eaten gummy bears? Yes. And when you eat gummy bears, do you take your gummy bears and be like, I'm going to kill you, and then you rip off their head from the stuff, but you do it slowly. You torture them, and you're like, no! And then you eat the thing, and they eat the body, and you're like, ha! And then most of you guys said last time, you're like, oh, Mr. Daldy, you know me so well. Right. So let's pretend that Mark's a gummy bear.
What? No.
And then I'm going to take your hair, I'm going to pull it up, I'm going to put your body down, I'm going to stretch it like this. Ah! What's going to happen to you?
My head's gonna come off.
Well, your head's going to come off, right? But I mean, if you were a gummy bear, what would happen to you?
Scared.
You would get taller and skinnier.
Hope I get taller.
Yeah. So look what I did. I took this parabola, and the red one is the regular one. We didn't change that. But I put a 2 there, and what it did is it made it taller and skinnier. That's how you change that parabola. What I can also do, and so do you see how the green one is skinnier than the red one? I didn't move it up. I didn't move it down. I actually just kind of took that thing, grabbed it by its head, and said, no, don't kill me. And then it moved the whole thing, stretched it vertically. And it shrunk it this way. All right, cool. Now, what if I put a negative out in front? What did that do?
Okay.
All it did, it didn't get wider. All it did was it just kind of went like this. Boom. That's it. It would be like if I painted this green, imagine if I painted this green arrow on a piece of paper. And then I took that paper and I went like this. I folded it in half. Across this line right here. And then the image that it made is just upside down. We cool? But how do I make it wider? I can make it wider by making it a fraction. See? I just made the green one bigger and I just made it a fraction. Essentially, that'd be like taking your gummy bear, taking the head, taking the feet, and saying, "Don't crush me!" Ah! And then it gets fatter. It gets shorter and fatter. Does that make sense to you? All right. Now, this vertex form right here is not the only way to describe a parabola. You have seen this before, ax squared plus bx plus c. Have you seen this before? Yes. You've seen it in your math class, and what you did to it was you applied to it the thing we call the quadratic equation. Now, our standard form is going to look a little different because instead of x's, we're going to have t's, right? And so what I'm going to do now at this point is I'm going to try to fit my parabola. I'm going to try to fit this, let's see, I'm going to do this. I'm going to try to fit this parabola $E$7. Okay, wait. Let me show you what I'm going to do because it will blow your mind. Hopefully it will blow your mind. All right. What I'm going to try to do is I'm going to try to figure out what the numbers A, B, and C are. See, A, B, and C? I don't know why I had it backwards a little bit, but hey, deal with it. I'm going to try to fit the numbers A, B, and C so that I can make my red line look like this blue line. Are we cool? And I'm going to try to see what the value of A, B, and C are and try to get it closer and closer and closer. Obviously, if A is equal to 0, what kind of line would I have? Think about this. If A were 0 in this problem right here, you would have a bx plus c. Hey, doesn't that look like y equals mx plus b, or y equals some number times x plus some constant? You would have no squared term in there because the A is 0. So it would just be a diagonal line. And we see that as true by looking at this red line. Look, it's straight. But if I make A 1, this is kind of a parabola. Now I have a question for you. Do you think A is going to be a positive or negative number? Is it going to be sloping up like this, or is it going to be sloping down? I want to try to match these two. You think it's going to be a negative number. Why negative? Because they should match, they should be facing the same way. Yes, I agree. Because they both face down. Yes, I agree. But I mean, think about this. What are we trying to emulate here? Starts with a G. Gravity. And which way does gravity pull? Downward, which is negative. So therefore, that's why that A is a negative number. Let's figure out what A is. So this is negative 2. Did I get closer?
I think you should go -6.
Negative 3. Let's do that. Ooh, getting closer. All right, let's go negative 6. That's what Mark guessed.
Alright, too much.
Too much. All right, what do you want? Negative 5. Oh, we're getting real good. Negative 5. That's.
0.75.
How's about negative 4.75? Huh. How's about negative 4.8? Closer. What about negative 4.9?
That's like perfect.
That's the closest I can get. If I put a C out in front, like let's make it 3. All I did was I pushed up the parabola up. So obviously C doesn't really, you don't want a C there. You want that to be 0. Does that make sense? So what I'm doing is I'm telling this thing to guess, and what I'm doing is I'm saying, okay, take this a and make it a times x or times t squared, and t is this cell right here. And then take this b and make it b times t, and take this c and make it just add c to the thing. We cool? So, and then I'm saying, okay, I want you to guess this, because what I'm trying to do is I'm trying to, obviously when we graphed this motion, it was a parabola, right? Now what I'm trying to do is I'm going to say, okay, fine, if it really is indeed a parabola, then I should have an equation for that parabola, and I'm trying to basically see if I can get a regular parabola, ax squared plus bx plus c, to kind of emulate, you know, the parabola that I see in real life. So I'm changing these parameters just a little bit to try to get an idea of what the parabola looks like. We cool? Now I want you to notice this number right here, negative 4.9. Okay? Let's do this monkey shot. Alright, so what I did here, here's another video that I tracked, is I got a monkey. And I dropped the monkey and I fired the cannon at the monkey. Now I put a parachute on this so it actually changed up to the experiment. But if you want to see what I actually did over here, or what some guys at MIT did, is take a look at this website right here, because it's actually really fun. It's only a minute long. Here. The monkey and the gun demonstration. Do you guys want to see it? You kind of want to see it. Alright, here, I'll explain to you guys what's going on while it's playing. Embedding is disabled as you requested to watch on YouTube. What's going on? What's wrong with that? Alright, fine. Let's just watch it on YouTube. There we go. Alright, here, use this website right here. I'll explain to you what's going on. Hopefully the advertisement doesn't pop up. I hate advertisements. Alright. So, what we're going to do is, let's pretend you're a biologist wants to shoot a monkey. Okay? Now, what the biologist will do is he'll take the gun and aim it straight at the monkey when the monkey is in the tree. Okay? Now, when he fires the gun, as soon as he fires the gun, the monkey sees the muzzle flash and knows, hey, a gun is trying to shoot me. I'm going to let go of this branch and fall. So the bullet will pass over my head. Does that make sense?
Yep.
But the monkey doesn't know physics. So therefore, watch what happens. And we'll talk about it. You see what happened? Here it is in slow-mo. There's the ball, there's the monkey, and the monkey just got killed. By the way, no animals were hurt in this experiment. This is a stuffed monkey, and that was a golf ball. No, it's not a real monkey. We didn't drop real monkeys and shoot them. Yeah, that was just a sound effect. Don't worry, the stuffed monkey didn't actually like go ah or anything. I'm just letting you know. Okay, don't freak out. Don't be calling PETA on me or whatever. You know. All right. So what's going on is the monkey drops and falls down. The ball falls and actually they meet at the same point and they hit each other. And where did the gun aim? The gun actually aimed at wherever the monkey was in the tree. Why is that? Why did the monkey and the bullet hit?
Gravity, because it falls down.
Okay, all right. So Mark is saying gravity. He's saying gravity's the answer. Okay, fine. What is pulling the monkey down?
Gravity.
Gravity. Agreed. What is pulling the bullet down? Gravity. Exactly. Is it the same gravity that's pulling the monkey down?
Yes.
Yeah, it's caused by the same thing. It's caused by the Earth. So therefore, they would fall at the same rate. Even though the bullet's being shot up in the air, it would be pulled down by gravity, which only acts in the vertical direction, by the way. And the monkey would be pulled down at the same time. I did the tracker version of this thing. But by the way, my tracker, when I did it, it missed. Why did it miss? Because I had a parachute on that monkey. So therefore, air resistance affected the monkey more so than it would have the bullet, and it didn't hit. But anyway, I tracked the X and Y position of the bullet for this experiment. There, I'll show it to you.
This is animated?
This isn't animated. This is a real video. It's just in slow motion.
Just missed it.
Yeah, I just missed it. All right, so then I take the X and Y data from that, and I'm plugging it in. And by the way, I also tried to fit the data to it. I did the exact same thing I did with projectile motion. And what do you guys actually? You know what I'm going to do is I'm going to delete this right here, and I'm going to bring that down. All right. So what number should I use? You want to try 3? Well, it's got to be -3, right? No, did that work? We're messing with A. Don't worry about this H and K and all of that kind of stuff. We're messing with an A number. -3 work? No, not even close. How's about -4?
6.
-6? Too much. -5? Okay, why don't we try -4.9?
4.95.
It actually, it's good. It was really good at the beginning, not as good at the end. Yeah. So -4.9. Notice something here. What do you notice? These are 2 different situations. What do you notice?
It's almost the same.
It's the same number. This A is the same number. All right. The last thing I did was I did a really cool one. You guys ever see this blob?
Yeah.
All right, and I don't have time to do the blob, but anyway, I tracked this blob version, and I'll tell you what. I'm gonna just send you guys the video, and I'll let you know that I tracked it. And I hate to say it, but I'm gonna have to leave on a cliffhanger because I have to go. I'm sorry. But anyway, here's the video for the blob. Is official Guinness Book of World Records. Check it out. And no, you do not have an assignment today.
Do you have any assignments this week?
Yes, you will have an assignment this week. Let me tell you what I'm prepping you for, what I'm going to be doing this next week. We're going to build a ping pong ball launcher because of a video that I saw that Victoria had. Okay? That's what I want to do for the next couple of weeks. I want to build a ping pong ball launcher.
See if you shoot it.
I want to measure all of this data. Not only do I want to measure it, I want to track it. That's why I'm trying to teach you guys Tracker. And then what I want to do is the week before school ends, I want to bring everyone on Oahu into the gym downstairs. And we'll set up a war zone. And we'll have people stand at little, at different points in the gym. And we'll fire ping pong balls at each other. And we'll keep score. That's what I want to do. And for you, Jenna, here's what's going to be the fun one. Is I'm going to send you the data for the ping pong ball launcher that I built. And then I'm going to have you on WebEx. And you can tell me the angle and degrees that I need to set it to in order to hit your classmates. And I guarantee you that the math that we're learning now is very useful. This is why I don't have many assignments, because I'm giving you small assignments to be able to help you. I'm giving you guys small assignments because I want you guys to be able to do this. So this week's assignments is basically going to be looking at projectile motion. And so we're moved on from one-dimensional motion to two-dimensional motion. But I'm sorry, I have to go. I got to finish my WebEx, and I'm done. So watch this video. I'm going to do that on Thursday. We're going to talk about that. By the way, next week we're putting a pause on all of this stuff, and we're going to cover in great detail a review for the HSA. So all of you who didn't pass the HSA, you got another shot on it on May 5th, I believe it is.
Yes.
And for those of you who didn't pass it, we want to make sure that you do pass it. You need to pass it. So we're going to review HSA all week next week. Got it? All right. Talk to you later. Okay, bye. Stop recording.